step we take, every move we make, every inch we measure, every map we prepare is a treasure. Every coordinate we estimate is a history, a legacy, a heritage. We are connecting link between the old India, the modern India, and the future India. We are the Survey of India, the National Surveying and Mapping Agency of India. We are recognized as the oldest scientific department of the Government of India, which works under Department of Science and Technology. And in the role of the nation's principal mapping agency, Survey of India bears the special responsibility of generating precise geospatial data and maps. We provide base maps for integrated development. The Indian Defence Forces and security agencies use Survey of India maps. The international boundary demarcation is another very important and crucial task carried out by us. The international boundaries are regularly inspected and missing or destroyed pillars are relocated. Precise geospatial data are also needed for all the citizen-centric developmental activities. We always ensure that all resources contribute with their full measure to the progress, prosperity, and security of our country, now and for generations to come. Survey of India has been generating voluminous field and digital data or information through systematic topographical surveys. The topography of the Indian subcontinent varies from the snow-covered Himalayan peaks of the world's highest mountains to the rich and fertile plains of the Ganges, with large undulating areas, thick jungles, deserts, mighty rivers, swamps, and a long coastline. And this makes systematic topographical survey all the more gripping. Survey of India has also been called upon extensively to deploy its expertise in the field of geodetic and geophysical surveys, environmental and disaster management, participation in Indian scientific expeditions to Antarctica, glaciology programs, and other projects related to digital cartography and digital photogrammetry, etc. All this is to provide basic data for science and technology requirements. It all began after victory in the Battle of Plassey in 1757, when some considerable portion of land came under the control of East India Company. They were interested only in revenue. To collect revenue, they required details of the area they had acquired, and for this they needed maps. The necessity of maps forced them to survey the areas they had acquired. An organization named Survey of Bengal and Major James Rennell was appointed Surveyor General of Bengal on 1st of January 1767 at Calcutta. Similarly, Surveyor General of Bombay was appointed in 1796 to survey the Bombay Presidency, and Surveyor General of Madras in 1810 to survey Madras Presidency areas. As the survey work expanded beyond these presidencies, the three were amalgamated into one in 1815, forming Surveyor General of India, with headquarters at Calcutta under Colonel Colin Mackenzie, who was then the Surveyor General of Madras. Since then, legacy has taken a drone tour and flew to 21st century. It will not be an exaggeration to say that the foundation of modern India coincides with the early activities of the department. From printed maps to digital versions to drone flying maps, Survey of India has always played an indispensable part in keeping up with the time and era. Survey of India has been and continues to be visionary enough to take a leadership role in providing user-focused, cost-effective, reliable and quality geospatial data, information and intelligence for meeting the needs of national security, sustainable national development and new information markets. Outstanding vision comes with an absolute sense of mission. Thus, Survey of India dedicates itself to the advancement of theory, practice, collection and applications of geospatial data and promotes an active exchange of information, ideas and technological innovations amongst the data producers and users who will get access to such data of highest possible resolution at an affordable cost in the near real-time environment. With the vision and mission combined, in the last more than 2.5 centuries, the entire country has been mapped with utmost dedication and hard work by a distinguished line of surveyors. Survey of India has been turning stones to innovate digitization of maps so that the digital maps can coordinate with the global positioning system, National Special Reference Frame, which deals with defining the framework of precise coordinates and heights for entire country, tidal observations and prediction of tides, gravity surveys and geomagnetic observations across country. Developing a three-dimensional model of Earth's surface on different resolutions, calling it the National Digital Elevation Model. National Topographic Template means preparation of topographic maps on all scales, aeronautical charts, special purpose surveys for airports or airfields of AAI, Navy, Coast Guards, map surveys of Indian Air Force, topography of all rivers, maps for disaster mitigation, forests, cantonments and other large-scale maps for special purposes. This includes surveying and mapping for citizen-centric developmental projects. Administrative boundaries include international and interstate boundaries. For International Boundaries Survey, the Survey of India carries out demarcation and relocation, preparation of international boundary strip maps, depiction of correct external boundaries of India on maps, scrutiny and certification of correct external boundaries and coastline of India on maps published by other agencies, advice on international boundary matters to Ministry of External Affairs. Almost similar tasks for Interstate Boundary Survey, including advice on interstate boundary matters to Ministry of Home Affairs, Supreme Court, High Court and other courts. Also preparation of administrative boundaries data up to village level. Demarcation of hazard line along Indian coasts as per Coastal Regulation Zone Notification dated 2nd July 2018, Ministry of Environment, Forest and Climate Change. Another key responsibility is toponymy. Whenever there is a natural place name to be changed, the state government shares the need to the center and center shares the issue with Survey of India. Survey of India takes a call and decides on the spellings of the new name of changes. This is applicable even to the names of railway stations in the country. Survey of India also determines the mean sea level for all coastal ports in the country. Mean sea level is observed and calculated for 18.6 years to get the exact reading. This data varies because of high and low tides observed in the water bodies due to orbit of Moon around Earth. The orbit of the Moon around the Earth varies, but after every 18.6 years, the Moon repeats the same orbit. Thus, the observation time is decided and followed. So, now you understand that the science of map making could have not been possible without the knowledge of the shape and size of the Earth and its relation with other celestial bodies. It is required for determining the coordinates of points on the Earth's surface, which are used for map making. We are doing this since 18th century and still continuing in the 21st century. So we have a variety of success stories to share. The bequest of over 250 years is the Great Indian Arc of the Meridian. It was the biggest scientific project ever undertaken. At that time, it was the longest measurement of the Earth's surface ever to have been attempted. It is 1,600 miles. A perfect survey took nearly 50 years, cost more lives than most contemporary wars, and involved equations more complex than any in the pre-computer age. This effort made India unable to know correct shape of Earth and thus opened the way of map making. Survey of India is credited with the identification and calculation of height of highest peak of the Earth, which we know as Mount Everest, proudly standing in the Himalayas. The highest peak of the world was first observed in 1847. It was initially designated as Peak 15. Further observations done between 1849 to 1850 and finally on 1st March 1856. The then Surveyor General announced this with the name of Mount Everest. Survey of India played crucial role in national building just after independence by providing accurate framework of coordinates and maps, which could form the basis for various projects we see today, such as Bhakra Dam, Bhilai Steel Project, Nagarjuna Sagar Project, Narmada Project, etc. And how can we forget the wonders of world present in India, like Taj Mahal? Checking the verticality of minarets of Taj Mahal was first carried out in 1957-58. Similarly, first measurement for checking the verticality of Qutub Minar was carried out in October 1964. These works are still regularly done. Many ongoing projects make the present and future interesting and energizing for Survey of India. Apart from the mandated work, Survey of India is also getting major developmental projects of national importance from different ministries and state governments. To name some of the major projects, we have the National Hydrology Project (NHP). The main objective of the World Bank-assisted NHP project is to improve the extent, quality and accessibility of water resources information and to strengthen capacity of targeted water resource management institutions in India. Survey of India is one of the central implementing agencies in the project. For this project, SOI is carrying out large-scale mapping on 1:25,000 / 1:10,000 scale for more than 8 lakh square kilometer area, and also to provide 50 centimeter resolution digital elevation model. Another project is National Mission for Clean Ganga. Survey of India has been entrusted to generate high-resolution digital elevation model DEM of 0.5 meter resolution and GIS for the part of river Ganga, covering up to 10 km extent on both sides of river using latest technology. The ambitious Swamitva scheme of Ministry of Panchayati Raj was launched by Honorable Prime Minister of India on 24th April 2020. It is being executed by Survey of India for mapping of all the villages in the country on 1:500 scale using latest drone technology. Examples of few other projects are Integrated Coastal Zone Management (ICZM), large-scale mapping for state governments of Karnataka for rural, semi-urban and urban areas, Haryana for large-scale mapping of entire state, Maharashtra for large-scale mapping of inhabited land in rural areas, and Madhya Pradesh. All these projects for state governments require ultra-high resolution data of 5 to 10 centimeter resolution using unmanned aerial vehicles. MOU signed with Indian Railways for very high resolution 3D mapping along railway tracks. Many more similar projects are expected from various ministries and state governments. A portal, Manachitra, where the open series maps in PDF formats have been made available to general public for download. In government to public portal, indiamaps.gov.in, the maps are available in vector formats with functionalities like route planning, finding directions to required destination, etc. Government to government portal for central and state government departments, wherein various government agencies can access the geospatial data generated by Survey of India. Mobile app Sahyog has been launched to enable the users like government departments, academic institutions, students and common citizens of India to use the Survey of India maps on mobile phones and to add the points of interest into the maps. Survey of India has initiated development of GeoAid model, which will enable the users to directly get height above mean sea level using GPS instruments. It will save considerable amount of time and money. The beta version of GeoAid model has been developed for the entire country and released. The development of higher resolution model is under process. To fulfill its mandate of maintaining the topographic data of the whole country, Survey of India is initiating the generation of high-resolution national topographic database on 1:10,000 scale. Also, the foundation ortho-rectified images on 1:500, 1:1000 scale with 10 cm accuracy and ultra-high-resolution digital elevation model DEM with 20 cm accuracy will be created. This will be done using unmanned aerial vehicles UAVs. The ease with which we, the Survey of India, handle the activities and take accurate and appropriate action is appraisable and applaudable. And for us, teamwork makes the dream work. We measure every inch of the country. We have expertise in scale, length, shape, area and angles. We are in charge of mapping the country, and all this requires capacity building and training. Early surveying instruments have been displayed in our museum. Let's have a look at equipments displayed here. Museum also contains some charts and posters illustrating the current surveying activities. The museum is annexed by a departmental library which contains some old books, documents and publications. Visitors appreciate the development in surveying technology and instrumentation by comparing the old instruments and techniques with the modern ones now in use. So, British perspectives of mapping India have been transformed into Indian concepts.
The Department of Science and Technology is completing 50 glorious years in the service of the nation through science and technology. This journey of relevance and excellence has not been a solitary one. All our autonomous organizations have played a critical role in driving forth with quality and focus and speed in their respective areas. They have excelled in their pursuits. I wish all the autonomous organizations and their scientists a very successful future. The future is coming at us at faster and faster speeds. I'm sure you'll be fully prepared to meet the challenges and create new opportunities and work for an Atmanirbhar Bharat that can be proud of its S&T depth and spread.
Existing in the tech-savvy world, we know legacy of past. And we are the blueprint of future. Pious land of India is our playground. So, join hands with us and know India now.